This is the fifth lecture of Engineering Materials and Material Science Fundamentals. In this lecture, we will be seeing imperfections in crystal structures. The first imperfection in crystal structure is point defect. So, in point defect, there are 5 categories. First is vacancy. In the crystal or the grain size, we have vacancy at particular location, like it is seen here. So this type of defect is called as in vacancy defect. In interstitial defect, there will be some particle of different material or the same material at the interstitial location between the atoms. So this is called interstitial defect. In substitutional, the location of the atom will be replaced by some other atoms of different material, and the rest two are the Frankel and Schottky. In Frankel, there will be self interstitial, like this atom is moved from its original location to some other location between these 4 atoms. So this is the interstitial defect, which is neutral, because in ionic structure there is a plus minus kind of charge, with like NaCl is Na plus Cl minus. So this particular positive ion will move its location, it will be self interstitial at some other location, and its entire charge will be neutral as it is self interstitial and it's moving its original atom to some other location. So this kind of defect will be neutral. In Schottky, the entire ion of plus minus will move from the material, so it will be a vacancy defect. There will be no atoms placed and they disappear in together, means they will be having a vacancy at particular location with both the charges not present, and this kind of arrangement has a neutral, positive or negative charge possible. So these are the point defects. The next is edge dislocation and screw dislocation. We call it as a line defect. So in this we have entire line of atoms which are going inside the plane will have extra line of atoms in crystal system. So here you can see these lines. These are the atomic crystal lines. We have this particular edge which is in between these two lines. So this kind of defects are edge dislocation, and it moves in the direction of Berger vector. So Berger vector lies parallel to this line defect, and it lies perpendicular, means Berger vector lies perpendicular to the edge but moves parallel. This edge dislocation moves parallel to the Berger vector. Similarly, we have screw dislocation. In this case, we have a line but it is spiraling downwards inside the material like a spring, and the Berger vector lies parallel to the screw but it moves perpendicular, means this dislocation will move perpendicular direction to the Berger vector. The next is surface or grain boundary defect. In this, the entire surface has a defect. Like the first is grain boundary defect, in which the entire orientation of particular grain, so this is particular grain, its orientation is different from the other grain. Likewise, other grains are also oriented in other directions. So this kind of defect in the material is called as grain boundary defect. In tilt boundary, we have different orientation of grain in the same plane. So this particular grain is oriented at this particular angle, and the other grain from here starts from here and it's oriented in other direction. So this is called a tilt boundary defect. So here it's a tilt of the boundary. In twin boundary, we have two grains exactly looking like a mirror image of each other. So this is a mirror image line on this right hand side and left hand side of this twin boundary. We have the mirror image of the two grains. So this kind of defect in this material is called as an twin boundary surface defect. In twist boundary, one plane has other plane oriented at other direction on top of it. So this blue color plane and this black color plane are on top of each other, but the atoms orientation is in different direction. Means in blue color it is at this particular direction, and in black it is at this particular direction. So there is some angle in this surface of these two grains. So this kind of defect is twist boundary defect. The last one is volume defect. So in volume defect, if there is a void inside the material, then it is called as a void defect, where the entire volume of the material is not present. And the stacking folds are different layers of material will stacked in different orientation and in different direction and forms a volume defect. The third is the inclusion of other phase. So in between the material there are some other bulk material of other element, or there is inclusion of some precipitate formation inside the material. So this kind of defects are volume defects. Thank you for watching this video. I hope you enjoyed it. Do share and subscribe the channel. See you in the next video.